Hi, my name is John. I will be going in Algebra 2 Common Core from Pearson book. Chapter 4, Section 7 is called Quadratic Formula. I'm going to be doing a couple of examples as well as proving the quadratic formula. Just sit back, enjoy the show, okay? First, we start with the function, which looks like ax squared plus bx plus c. That's the standard form of the equation. And we're going to set it equal to 0 to find the roots. The roots being setting equal to 0, or sometimes they call this the zeros of the function. I am going to be proving the quadratic formula pretty fast, so just sit tight. You don't have to worry about it too much. Most teachers will not have you prove the quadratic formula. Anyways, to get this guy to be a 1, I'm going to divide it by a to both sides. A divided by a. A's cancel, you end up with x squared plus b over a x. I'm going to move the c over a to the right-hand side by subtracting c over a. Well, 0 over a is just 0, so you end up with negative c over a. To complete the square, I have to take this divided by 2. That's what you learned from last section. So it becomes b over 2a. And then I'm going to just square that. If I square the right side, I square the left side. I'm going to add b squared over 4a squared. Okay, I'm going to add like terms. I'm missing a 4 on this one, so I'm going to multiply top and bottom by 4. I have to square it, so I have to multiply the bottom by a, multiply the top by a. Cleaning this up, on the denominator, I get 4a squared. On the numerator, I get b squared minus 4ac. I'm going to factor the left side, drop the x without the squared, drop the sign. It's b over 2a. Or you could just take b over a and divide it by 2 squared. And now what we do is we square root both sides, the left side and the right side. On the left side, we cancel that because it's inverse operation. It becomes x plus b over 2a is equal to, on the right hand side, and it was square root of b plus or minus b squared minus 4ac all over the square root of 4a squared. I know what the value of square root of 4a squared is, which is 2a. End up with plus or minus the square root of b squared minus 4ac. Oh, we're almost done. Do you notice it kind of looks like the quadratic formula? All we have to do is subtract b over 2a to both sides. So finally, x is equal to negative b, these cancel. Negative b plus or minus the square root of b squared minus 4ac all over 2a, common denominator. Whoop, there it is right there. That is the quadratic formula. It was pretty simple. The process is called completing the square. So I'm going to do an example for you and then go over some other things as well. The first thing I'm going to do is, let's start with an example. You have x squared minus 4x plus 3 is equal to 0. Well, let's see what happens now. My a value is equal to 1. There's a coefficient, the leading coefficient is 1. My b value is negative 4. Right there, the leading coefficient for the linear term. And my constant term, c, is 3. And always write the formula down first until you get it memorized, forwards, backwards in your sleep. Negative b plus or minus square root of b squared minus 4ac all over 2a. Negative b was negative 4, which is positive 4, plus or minus the square root of b squared. Negative 4 squared is 16 minus 4 times 1 times 3 all over 2 times 1. There's a 1 right there. Simplifying that, I get 4 plus or minus the square root of 16 minus 12. 16 minus 12 is equal to 4. Plus or minus square root of 4 all over 2. It's going to be 4 plus or minus square root of 4 is 2 all over 2. I'm going to break this up because you really should break this up to make it easier on yourself. 4 plus 2 over 2 or 4 minus 2 over 2. 4 plus 2 is 6, over 2 is 3. 4 minus 2 is 2, 2 over 2 is 1. Those are your two solutions. So x equals 3, comma 1. Well, before we go on to the next problem, we want to go over this a little bit more in detail. Well, the first thing you should notice is this right here. When you get a real nice answer, like 3, 1, nice whole numbers or integers, this is probably factorable. What do I mean by factorable? Well, let's try this problem one more time. I'm going to use blue this time, okay? I end it with x minus x squared minus 4x plus 3 equals 0. It's probably factorable. X plus means they're both same signs. They happen to be both minus because of this, minus 4. And then 3 and 1, doesn't matter which one. And then using the zero product property, x minus 3 equals 0. X minus 1 equals 0. So x equals 3, comma 1. Whoop, there it is. So you could have actually just solved this out by factoring. The quadratic formula is probably the last resort. If you can factor it, it's a lot easier to deal with because you don't really want to use all of this calculation stuff, whereas factoring is a lot easier. Second thing that you should notice is this right here, the b squared minus 4ac. We talked about it about 30 seconds ago. This value is very, very important. The b squared minus 4ac, that's called the discriminant. C-R-I-M-I-N-A-N-T. The discriminant, there's an N right there. The discriminant means to discriminate. It discriminates between what kind of solutions we have. So let's go on to see what kind of solutions we get, okay? Let's look at this one more time, the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we call the discriminant, I like to call big D for discriminant, is b squared minus 4ac. So it actually should be is equal to negative b plus or minus the square root of d all over 2a. So let's see what happens when d is greater than 0. What's another word for greater than 0? A number that is greater than 0 is just positive. So every time I say the word greater than 0, it means positive. Obviously, d is less than 0, it's negative. D is equal to 0, that means it's what's called a double root. That means that you're going to have a root something like this. It's going to hit the x-axis at one point. That's called a double root. Okay. Let's suppose d is greater than 0. You're going to have two roots. Two real R-E-A-L roots. That's your solution for something like this. If d, that's for that right there, d is less than 0, if you take this number inside this radical, it's negative, wouldn't that be imaginary right here? You haven't looked at imaginary numbers very much, but you will look at imaginary numbers later on. These are called, if d is less than or equal to 0, it's called two imaginary conjugate roots. There's a reason why they call two imaginary conjugate roots. You'll learn about that in 4.8 or 4.9 later on. But less than 0 means it's negative. You'll have two imaginary conjugate roots, or sometimes there's no real solution, or no real solution. It's not real because it's imaginary. And the way we look at it graphically, it looks something like this. Does not cross x-axis. You notice that right there? Does not cross x-axis. That means no real solution. So these are the discriminant. How we discriminate is if it's greater than 0, less than 0, or equal to 0 inside this radical right here. Good luck on your homework, and if you have any questions, let me know. Thanks. Bye.